Force. Moment of force. Torque. Definition. The moment of force or torque is equal to the product of the magnitude of the force and the perpendicular distance of the line of action of the force from the axis of rotation. Units of moment of force. Unit of moment of force is equals to unit of force multiplied to unit of distance. Therefore, SI unit of moment of force is Newton meter, while the CGS unit of the moment of force is dyne centimeter. Common examples of moment of force: opening a door, turning a steering wheel, spanner used to loosen a nut. The turning of a body about an axis depends not only on the magnitude of the force, but also on the perpendicular distance of line of action from the axis of rotation. Larger the distance, lesser is the force needed to produce turning effect, and vice versa. Couple. Two equal and opposite parallel forces not acting along the same line form a couple. A couple is always needed to produce a rotation. Examples: turning a water tap, tightening the cap of the bottle, turning a key in lock, turning a steering wheel. Equilibrium of bodies. When a number of forces acting on a body produce no change in its state of rest or of linear and rotational motion, the body is said to be in state of equilibrium. Kinds of equilibrium: static equilibrium, dynamic equilibrium. Conditions of equilibrium. The following two conditions must be satisfied for a body to be in equilibrium. The resultant of all the forces acting on the body should be zero. The algebraic sum of moments of all the forces acting on the body about the point of rotation should be zero. That is, the sum of the anti-clockwise moments about the axis of rotation must be equal to the sum of clockwise moments about the same axis. Center of gravity. Definition. The center of gravity of a body is the point about which the algebraic sum of moments of weight of all the particles constituting the body is zero. The entire weight of the body can be considered to act at this point, howsoever the body is placed. Center of gravity of some objects with regular uniform distribution. Circular ring, center of ring. Circular disc, geometric center. Triangular lamina or scalene triangle, the point of intersection of medians. Rectangle, the point of intersection of diagonals. Parallelogram, the point of intersection of diagonals. Square, the point of intersection of diagonals. Rod, the midpoint of rod. Solid or hollow cylinder, midpoint on the axis of cylinder. Uniform circular motion. When a particle moves with a constant speed in a circular path, its motion is said to be uniform circular motion. In such a motion, a particle travels equal distances along the circular path in equal intervals of time. So the speed of the particle is uniform, but the direction of motion of particle changes at each point of the circular path. The continuous change in the direction of motion implies that the velocity of the particle is non-uniform or variable. That is, the motion is accelerated. Difference between uniform linear motion and uniform circular motion. In uniform linear motion, the speed and velocity are constant and acceleration is zero. That is, uniform linear motion is an unaccelerated motion, while in a uniform circular motion, the velocity is variable, although the speed is uniform, so it is an accelerated motion. Centrifugal force. A force acting on the body in a direction away from the center of circular path is called centrifugal force. Centrifugal force is in a direction opposite to the direction of centripetal force. It is not a real force, It is a fictitious force assumed by an observer moving in a circular path along with the body. Centripetal force, a force acting on a moving body in a circular path in a direction towards the center of the circular path, is called centripetal force. Centripetal force examples: planet moving around the sun in an elliptical path, stone tied at the end of the stirring world in a circular path, electron moving around the nucleus in an atom.